Hello friends, I am Jitesh and welcome to my channel. Today we are going to discuss a new chapter, new concept, that is conic sections, which will give us an idea about circle, which will give us an idea about the upcoming chapters such as circle, hyperbola, parabola, ellipse, those chapters. And before going to that concept, small sentence, that is, if you are new to my channel, kindly subscribe to my channel. Okay, and don't forget to click that bell icon. Okay, you might have noticed many shapes and curves in your daily life, such as a wheel and a wheel, that is circle, right? Similarly, when when a bullet is fired from a gun, you might have noticed like this, when a bullet fires a gun, the the path of the bullet is parabola. Means you might have already read about the in projectile motion in kinematics. Okay, and that is parabola, which will understand in today's topic. Okay, and also when the earth when earth is revolving around the sun, the orbit of earth is the shape of ellipse. That's not circle, it will be it will be like an extended circle, but that's ellipse. And also we have an another curve, that is hyperbola. Means which you have seen in the factories, these shapes, these are like furnace. Okay, these are these are these we get in a process, but in the geometry that we will discuss today. Okay, now entering into that, first to get that, first we should take an axis and another line, generator, and that generator should be intersecting with this line with the axis at an angle theta, some angle theta, and that is called generator. When it rotates in such a way, when it rotates, we get at an angle theta, we get an right a shape in such a way that it is called that double napped right circular cone or double right circular cone. And which double right circular cone means two circles, two cones will be there in this way. Okay, we get those shapes and curves. I said those circle, parabola, ellipse and hyperbola, we get those when we intersect a plane with this right circular cone, double napped right circular cone. If in this video you can in this animation you can imagine how it forms when this plane intersects with this double napped right circular cone. At that point, that at that intersection, means those two cones are meeting at some point, no, that the point will be formed, and that point is vertex. And when we intersect this plane with with that cone in up or down anywhere at an angle is equals to 90, means horizontally when we intersect this plane at an angle 90 with that cones, with any of the cone, we get a shape that is called as circle in this way. And another one, ellipse. Okay, when we tilt that, means the angle theta will be from 90 to 180, we get this shape called ellipse. And also when we tilt that still more, and when this plane will be parallel to this generator, we get a shape called parabola. And when we intersect that in a vertical way, means it will be parallel to the axis, then we get a shape that is hyperbola. Okay, now we will see the definition of this is the definition of conic sections. This conic sections definition is this: a conic is locus of a point which moves in a plane such that its distance from a fixed point is constant fixed point is in constant ratio to its perpendicular distance from a line. Okay, from a fixed line. I will show how it is. If we take a line, there will be a line like this. This is a line. Okay, this is of how much distance or something. Its equation is some equation we don't bother about now, just about the concept, how it will be. Those all we will see in the lessons, chapters itself. Okay, this will be, this is a line, this is a fixed line, it doesn't move here or there. This line is called directrix line. This line is called directrix line. Is directrix line. Okay, and a fixed point, here, we take here a fixed point, that is called focus, and that focus will do some work. Okay, focus, this is called focus. We will denote it with P. Okay, P, and we'll take a locus somewhere. Locus is a moving point, means it will move and make if that locus is there, if it from a fixed point at a distance r, if it rotates, then it is called then circle will be formed. Similarly, so it is a variable point. Locus we will take here. If we take here, and this locus we'll denote this as S. We'll denote this as P, x comma y. Mostly, generally, many will use this. This as will denote locus with P. Okay, and here what's the thing is, in a plane such that its distance from the fixed point is in constant ratio to its perpendicular distance from the fixed line. Okay, its distance from the fixed point. This is the fixed point. That focus is the fixed point, and perpendicular distance from the fixed line. This is the perpendicular distance. Okay, perpendicular distance, and we'll denote with this with M. Not only there, means see, if we take the locus here, then this will be the perpendicular distance, and this will be the, that will be the, what's that called, locus. Okay, and if we take the point here, then not here, if we take the point here, then this will be perpendicular. This ratio means that ratio means this is called focus, fixed point, and this fixed line is called directrix line, and the ratio of that should be will be constant. Okay, that is conic now. So that ratio means this distance PS. I'll remove this one. PS by PM. Okay, PS by PM ratio should be constant. That constant is called as eccentricity, denoted by E. Okay, and when a parabola is formed, see, if a parabola is there in this way, this point, if we this is the here will be the focus. We will take here the focus because we are not taking exact dimensions now. This is focus, and this if this is the, see, these all are the points which are in the constant ratio, means see this and this, wait, I will show that. This ratio by this ratio means PS by PM will be constant, means the way that not only one point, many points will be there with which PS by PM. See, I will say now, for a parabola, the eccentricity E, PS by PM should be 1, and for a ellipse, E, PS by PM will be less than 1, And for a hyperbola, E is equals to PS by PM will be greater than 1. Okay, will be greater than 1. So here if we take that parabola case, here if this is the directrix line and this is the point, means this is the parabola, here there will be focus. If we take the point here, here the PS by PM will be equal to here PS by PM, means the points where the ratio is 1, joining those all set of points, means the locus, all joining the all set of points, we will get the parabola. And similarly hyperbola, ellipse, those all we will get. Okay, in the next lesson we'll this is the concept of conic sections. This gave an idea about those conic, means these sections, parabola, ellipse, hyperbola, those. So next class will be on circles. And thank you for watching this video. If you like my explanation, kindly subscribe to my channel.